This is the AlphaWise U20 mix, and today we'll see how it does as we attempt to get some serious output from a single 6.5-inch subwoofer in this brand new take on the classic bass tube. Stick around. This massive box comes to me by way of GearBest, and right away here's a rather large build plate, a bass, a box of accessories, and a gantry with 2 extruders. I am genuinely amused by the sheer size of this machine. In fact, if you look from over here, the base actually extends beyond the table. The smaller box contains your typical assortment of tools and accessories. A little bit of PLA, a scraper, a couple of spool holders, a USB cable, some brackets, a surprisingly short power cable, some nippers, a stick of glue, a bag of screws, a set of Allen keys, zip ties, and for some reason a spare end-stop switch. Anyhow, the gantry attaches to the base with a set of 4 screws, and then a pair of these brackets locks in for additional reinforcement. This seems like a reasonable provision given that the spool holders sit along the very top and are subject to sway. All the cables are zip-tied in bundles along the sides and there's only a few things to connect, namely the 2 steppers for the Z-axis, one of the extruders, a consolidated ribbon cable for the other extruder plus the hot end, the X-axis stepper, and the X-axis end stop. So we've attached the gantry, the T-shaped fixtures, some bicycle handles, and all the harnesses. That's it for the instructions. I'll go out on a limb to assume that this goes here, and once the power supply is live, this button launches the user interface. Right away, the machine performs a power on self-test, which I like, but it also indicates a straight out-of-the-box failure, which I do not, as it would appear that one of the thermistors or the heating elements isn't responding. I brought this up to GearBest. They in turn had a chat with AlphaWise. 2 days later, a response came in form of this package, and in it, a replacement hot end, a filament guide, and one complete lack of instructions, which hopefully means that there is no wrong way to perform this repair. That said, I decided to start at the business end, removing the fan housing for a better look around. The heater block is held in place with this retention screw, and once it is maneuvered out of the heatsink, we can follow the bundle of wires to the back of the printer where it disappears into another housing. So that comes apart. There's the harness for the heater block, out with the old, in with the new, and once everything is rewrapped, reassembled, and refastened, the new heater block is loaded into place. Also, it probably wouldn't hurt to tighten down the heatsink. I'm pretty sure that's not supposed to wobble. Finally, I decided to have a look under the bottom cover on the off chance that something hadn't been connected to the main board or to the build platform. Everything appears to be in place, so let's give this another go. Once again, the machine performs a power on self-test. Unfortunately, it still indicates a failure somewhere along the thermal circuitry. So that's another line of dialogue with GearBest, and as we wait for an answer, let's talk acoustics. This is a recent addition to the 2000 series from Audio Dynamics, a 6.5-inch subwoofer addressing the 400-watt power range. And as is typical of smaller piston area drivers with high motor strength, when used in a generic vented enclosure they tend to be very efficient near the system's resonant frequency, yet very inefficient everywhere else. It's what we call a one-note wonder. This becomes less of a concern as you add more drivers, but if one is all that you want, then there's still a few ways to redistribute the efficiency. And one of them is to add a second reflex stage, a hidden party piece of the enclosure design for today's project. And since I am reviewing a dual extruder machine, so too I've modeled the enclosure as a dual color print. Have a look. Inspired by the classic bass tube form factor on the outside, you'll find 2 separate compression chambers on the inside. The panel that separates them also forms the base of the vent, which runs through the passive chamber to the opposing wall. There, the 3 pillars extend onward to make contact with the far end of the chamber, effectively supporting the vent from both ends. The terminal plate is modeled with a strain relief that guides a length of cable, mid-air, through the passive chamber, through the separating panel, right to the sub. There's also a pair of vents guiding the acoustic pressure from the passive chamber across the enclosure out into the open. The 2 outer shells are designed with these wraparound accents as a way to take advantage of the machine's dual extruder capability. And as you can see here, I have outlined them with a bit of a notch to help keep them prominent even as a single color print. Performance-wise, the enclosure is designed as a light-hearted middle finger to all the bass tubes that have come before it, with a flat response between 20 and 70 Hz at the headrest of my Chevy Sonic hatchback. I'm also hoping to register in the mid 130s on the Termlab, but for now let's get back to the printer. And the latest word from AlphaWise is that I must have a defective mainboard. So that's another impromptu FedEx package, this time containing a ribbon cable and a replacement board. All things considered, this is not looking very good for the manufacturer, but you know what? Lemons to lemonade. At least you get an intimate look at the guts of the machine, so on with it. The cover is removed yet again, and right away I take a bunch of pictures just so there is no confusion as to what goes where on the new board, especially given the number of harnesses that I have to unplug and reattach. With the new board mostly in place, I also noticed that the location of the J3 socket is slightly different from the original. Nevertheless, with everything in its proper place, I removed the original ribbon cable, that's the one that attaches up here, and ran the new one back to the board. I was also advised to update the firmware, which, oddly enough, installs from a secondary SD card located on the back of the screen. Afterwards, the bottom cover is replaced, hopefully for the last time, and the machine is returned to its upright position. Now let's all cross our fingers and... holy frickin' crap, it lives! The power on self-test completes without incident and I'm greeted with the main menu. So I guess this is where I make the proper introductions. This is the U20 Mix from AlphaWise, a dual extruder machine with a build volume of 300 by 300 by 400 mm. And my initial experience notwithstanding, there is actually a lot to like about the general design. Right away, it's big. I mean, look at how far I'm having to pull back just to get this thing in frame. I'm also happy to see the extruders mounted along the rail for the X-axis as opposed to, say, at the top of the gantry. This keeps the Bowden tubes short, mitigating any potential retraction issues. The whole thing rides up and down courtesy of two steppers for the Z-axis, and I'm also glad to see the rails for the Y-axis spread as far apart as they are. Generally speaking, the broader we make that stance, the lower the odds of the build plate teetering side to side. I also like how the brain box doesn't run the full depth of the machine, leaving the underside of the build platform easily accessible for any potential maintenance or upgrades. All in all, great design, questionable execution, but let's just see how it works when it works. My first order of business is to level the build plate, and the user interface makes this very easy to do. Once I'm satisfied with how the platform is seated, it probably wouldn't hurt to fine-tune the Z offset, especially given that I did replace the entire hot end. Again, very intuitive, and from there onward the machine can auto-level using the inductive probe. So before we proceed with the feature build, let's fire off a quick test print from the included SD card. The machine conducts a 9-point bed leveling test, and once everything gets up to temperature, it begins to print, or so it thinks. As the nozzle jitters about in mid-air, the only indication of what's happening comes in form of the left extruder clicking as though we have a jam. This seems next to impossible on a brand new machine, but as I attempt to feed some filament through the nozzle, clearly there's an issue. And in case you're wondering, the same thing happens with the right extruder. The gears are turning, but only to grind away at the filament. Now, at this point, you may be thinking, "F this." But as a last-ditch effort to get this contraption up and running, I decided to swap back to the original hot end. It certainly fits a lot better into the heatsink. Afterwards, the power on self-test confirms that there was never anything wrong with it. And after a quick recalibration, we have filament flow. The test print completes with one major layer shift on the X-axis, which does not inspire confidence, especially for a model that's less than a centimeter tall. Then again, this isn't my G-code, so I can't vouch for how the model was sliced. Nevertheless, I think it's about time to get on with the feature build. Here's the filament that I bought for the occasion, and I got as much as I did because I'm also bringing the infill up to 40%. If you wanna know why, check out the video where I compare PLA to 5 different types of wood. Long story short, the print should perform roughly on par with MDF. So, I'll kick things off with the internal vent panel. It's a single color print with no supports and it shouldn't give the machine any trouble. Here's a look at the first layer. A little bit of infill. And by the time it's done, I have to say that I am not the least bit disappointed with how it turned out. We did lose some resolution on the X and the Y axis toward the very top, but that's only to be expected as the further up we go, the more we rely on the print itself for horizontal stability. The metal build plate did an excellent job in terms of adhesion. Here, I give it a little bend, just enough to slip the blade in, and a few seconds later we have what looks to be one hell of an immersion blender. Next up, something a bit more challenging. This is the back half of the outer shell. A dual color print with internal supports, once again printing with a 40% infill. And now that we've reached the accent panels, I can show you how the color changeover happens. So here you can see the machine working on the black part of the layer. When it's done, the filament retracts and the nozzle travels over to the prime pillar. The other extruder feeds in the orange, and what's left of the black is purged onto this arbitrary structure. Afterwards, the nozzle returns to work on the orange part of the layer, and so on in that fashion as the enclosure takes shape. It is a painfully slow process, but if you're getting ready to drop a comment about this being a waste of time, bear in mind that it's the potential that paves the way to convenience. Your smartphone wasn't always a smartphone, and it took a few early adopters logging around some pretty gnarly mobile computing gear simply because it was possible, not because it was practical. And it had to be worth the trouble back then for it to become the convenience it is today. So in that regard, I tip my hat to anyone who doesn't wait around for the mainstream. Anyhow, off the soapbox and back to the print, because I'm about to perform the world's fastest filament swap. It occurs to me that whichever color goes on standby, it retracts about 5 cm up the Bowden tube, and since there is no filament runout detection, there is nothing stopping me from just pulling it out entirely, changing spools and feeding the new one right back in, all but those 5 cm without ever pausing the print, which appears to have worked, and the machine is none the wiser.
See what I did there?
Total downtime 0 minutes, 0 seconds. Days later, the print completes without much ado, and again it did not turn out half bad. The build plate kept a firm grip all the way around, and once it had gotten a chance to cool, the model simply popped off without me having to use the Raptor blade. 240 hours and 3 kilograms of filament into the print, I can definitely sense the machine trying to redeem itself. Next up is the front half of the outer shell, once again a 40% infill dual color print, though this time perched on a bed of external supports forming a 14mm tall inset around the mounting hole. I'm obviously not taking it easy on this machine, then again you don't buy something like this to print a little fish stick. This is 1.27 cubic feet of build volume, and I'm perfectly happy to fill a good bit of it before I decide whether or not it's any good. That being said, despite the rough beginning and given some properly sliced G-code, the machine does appear to hold its own with larger, heavier duty multicolor prints. And once this one is finished, let's take a moment to acknowledge my personal record for the longest continuous runtime of 8 days, 17 hours and 53 minutes, consuming nearly 2.5 kilograms of filament. Once again, the flexible build plate releases the print without much effort, and upon closer inspection, things continue to impress. What's more, with the front half of the outer shell complete, all that remains is the terminal plate, which is being printed with a solid infill. So there's that, and now we return to the workbench to get the pieces ready for assembly. Right away, all these supports have to come off. There's also a bit of stringing which can be taken care of with a heat gun. The internal supports prove a tad more stubborn, though once they're out, at long last, all the bits and pieces are finally ready to come together. And with that, we can move on to the wiring. Here, it's pretty much the same story as with my other projects. The binding posts are threaded into the terminal plate, except now the wire comes in through the strain relief and is wrapped directly around the posts. A dab of solder to keep it from unwinding, a couple of nuts to hold it in place, and it's ready to go in. Here's Sophie's hand applying the JB weld, and here's mine pressing the plate flat against the inset. A couple of sandbags should keep it there until the epoxy cures. Let's make that 3. Next, we'll want to bond the internal vent panel to the ledge along the other half of the enclosure. And here I'll use a set of these wooden blocks to help distribute the clamping force more evenly. A helping hand, or two, from Sophie, and we're all set for the next step. This is where the two halves come together. What I'm setting up for here is a test fit to ensure that these vent supports make a solid connection with the opposing wall. So when I take this back apart, the little bits of blue tack should be squished flat, either against the supports or against the inner wall, which they totally are, mostly against the latter. And this is a positive reflection on the dimensional accuracy of the individual prints. Anyhow, let's get this thing closed up. Here's another batch of JB weld going into the groove, and a generous glob of it spread across the 3 pillars. When all is said and done, the vent will double as an axial brace, making the enclosure insanely rigid along the baffles parallel with the sub, as it is already abundantly rigid on the radial axes. Before we load the sub, there is still a matter of sealing around the speaker wire, and as you can see, I designed the through hole with a chamfer to serve as a tiny pull for the epoxy. So with the wire clamped out of the way, the final glob of JB Weld settles in to form an airtight seal. And now we can drop in the sub. At this point, if you're a frequent visitor to the channel, it should come as no surprise that I like to seal my subs with blue tack. However, if this is our first encounter, then...
Surprise.
That's my pop for you. Always full of surprises.
And I'm not your pop, though you should consider subscribing. Anyhow, the coils will be wired in parallel, as that is also how I modeled the enclosure. And after a few minutes of screwing, the build is finally complete. 2,570 layers from one end to the other, forming what is probably the most structurally advanced 3D printed bass tube in existence. At least as of this video, and I'm sure that someone can fact check me in the comments. So let's get this out to the car, bring the amplifier back to life, and wire this thing up. We'll begin with a frequency sweep using the new UMIC 2 from Mini DSP. By the way, if you're interested in an in-depth look at the microphone, including the unabridged version of this test, complete with some anechoic analysis in the Audio Dynamics sound room, be on the lookout for my upcoming Mini DSP video. For now, let's just aim this thing at the headrest and acquire some data. The response has a bit more of a downward slope than what I had predicted, but otherwise not bad, at least along the part that matters. And it sounds unlike any bass tube that I've ever heard, in a good way. That being said, it's time to grab some headphones or pull this up on your main speakers, because coming up next is the passenger seat demo. And speaking of loud, let's get this thing on the Termlab. Sweeping at volume points to 50 Hz as our target frequency, and we can excite that resonance even further with the enclosure positioned like this. So, mind your ears as I neglect mine and...
50 cycles.
Whew. 136.2 decibels from a single 6.5-inch speaker with just under 600 watts. That is the sound of some 3D printers getting ready to be purchased. But will it be this one at just over $400? Well, you tell me. Having watched the entirety of my experience with this machine, some of you will undoubtedly view the level of maintenance as commonplace for the 3D printing hobbyist. Others may find it highly unacceptable. Thankfully, the odds of the machine cranking out prints like these are a lot higher than the odds of you receiving a lemon. That being said, once operational, the machine did complete a 445-hour print without a single hiccup. Sure, I could have used a larger nozzle and cut that time in half, but the whole point of this review was to introduce a challenge for the machine to overcome, which it did. And now I have a souvenir crafted at 0.2mm resolution. I also made the STL files available in Thingiverse, so if you're feeling adventurous, all you really need is a single AD2206 and about 3 weeks of nothing better to print. Furthermore, if you know of anyone else looking for a high-performance, low-profile subwoofer, consider bringing this project to their attention, and you can check the links down below for all the relevant products, materials, and other resources. Don't forget to rate the video as you see fit, and as always, comment down below with a breakdown of your listening gear and your thoughts on the sound demo. I'm pretty sure I've already recommended subscribing to the channel if you haven't already, so with that, I will see you in the next one. Cheers!